In this video, we're going to learn how to find the range of a function. So what is the range of each function defined by a graph below? But first of all, what is the range of a function? What does that even mean? Well, the range of a function is just the set of output values of a function. Now, for functions defined as graphs, like these ones here, the output values of the function are really just the y-coordinates. So the range of the function becomes just the set of y values that the function takes on. Now, this first function here takes y values that are higher than this y value, and that y value is -1, -2. That y value is -2. So the y values are greater than -2, and how far does it go up until? Well, the highest y value occurs at this point over here, and that's the y value of 1, 2, 3. Now, since that's a filled-in circle, that means the function actually attains the y value of 3, so we should have less than or equal to on this hand side. And to write this nice and compact, we can write this as interval notation. -2 is less than y corresponds to a parenthesis because equality is not allowed, so -2, then comma 3. With a bracket because equality is allowed there. So there we go. There's the range of the function. Okay, so how about this function here? Just a straight line. What's the range of this function? Well, what are the y values that this function takes on? As the function goes to the left, it keeps getting lower and lower, and it keeps getting lower without bound. It doesn't ever stop getting lower. There's an arrow on the function, so that just means it goes forever. Likewise, as we go to the right, the function keeps getting higher and higher. There's an arrow there, so it keeps on getting higher and higher forever. So it really takes on all the y values because it's going up forever and down forever. And since it covers all of the y values, the range is then all of the real numbers, which can be denoted in interval notation as -infinity to infinity. So there we go. That's the range of this function. Okay, so how about this third graph here? Again, we want to find the range, so we're looking for the y values here. Now, this function is a bit of a peculiar function because it stays pretty flat until stepping up, stepping up, stepping up, stepping up. But it doesn't cover the y values in between steps. It only covers a single y value at each step. So at this first step, the y value is -1. At the second step, the y value is 0, of course. At this third step, the y value is 1. At the next step, the y value is 2. At the next step, the y value is 3. So the y values are only -1, 0, 1, 2, and 3. Nothing in between, just those 5 numbers. So the range then is just the set of those 5 numbers. -1, 0, 1, 2, 3. So there we go. There is the range of the function. Alright, here are some more problems. What is the range of each function defined by a table below? Again, the range is just the set of outputs. So we really just have to look at all the output values in the table. In this first table here, the inputs are x, the outputs are f of x, so we're looking at 7, 7, 8, and 9. Those are all of the output values. Now when we turn those output values into a set, we always remove the duplicates. A number is either in the set or out of the set. It doesn't matter if it occurs more than once. So when we write down the set of outputs, we'll only count 7 once. We'll only write that down one time. So 7, 8, and 9 are the set of outputs. Therefore, that is the range of this function f displayed in that table. It's the same idea for the function g in this table here. T are the inputs. G of t is the output for each t. So we've got outputs 5, 1, 4, 8. There aren't any duplicates, so we're going to write them all down in our set. And why don't we write them down in order, just so that it's nice and clean. So start with 1, then go to 4, and then 5, and then 8. So there we go. There is our range. Here's the next problem. What is the range of each function defined by a mapping diagram below? So the mapping diagrams are kind of like tables, except they're jumbled up a little bit. So the function going from x to y actually maps 1 to 5, 4 to 2, 2 to 17, and 3 to 9. But nevertheless, the range is still the set of outputs. So it's all those values that the function maps to. For this function here, this function maps x to y, so we should be looking at the y values that the function maps to. So it maps to the y values 2, 5, 9, and 17. So this is our set of outputs. 2, 5, 9, and 17. And therefore, that is our range. Alright, this next function maps 4 to 0, 5 to 1, 8 to 0, and 9 to 1. So some of these outputs are repeated. For example, 4 and 8 both map to 0. But for the purposes of computing the range, this doesn't really matter because we just want the set of outputs. So it doesn't matter how many times they're repeated or not. If they exist as an output, then they're in the set. So the two outputs here are 0 and 1. So that is our set, 0, 1, which forms the range of this function from t to z. Here's the final problem. What is the range of the function y equals 2x plus 1, where x is in the interval starting at and including -3, up to but not including 3? Well, again, the range is the set of output values So that's the set of y values for this function. Y is the output, whereas x is the input. So why don't we go ahead and graph this function, and then we can take a look at the y values. So graphing this function, we see it has a y-intercept of 1. So let's plot that right over here at 1, and then it has a slope of 2. So it goes up 2 over 1 every single time. Now it only goes until 3 in the positive direction. So once we hit 3 over here, we should make an open circle. Let's go ahead and keep going. So up 2 over 1, up 2 over 1, but we've hit 3 here, so we put an open circle there. All right, and now we go the same idea in the opposite direction. Now it's down 2 and backwards 1, because that's really just equivalent to up 2 and over 1 when we go forwards. So keep doing that. And then we stop once we hit -3 as the x-coordinate here. So we'll stop here, but -3 is included because there's a bracket in that domain. So stop there and put a closed circle. And now we can go ahead and connect it up with our line. Here we go. There is our line. Well, it's really a segment, but there we go. So we're looking for the y values that the function ranges between. What's the lowest y value? Well, that's right over here. So let's count down. -1, -2, -3, -4, -5. That's the lowest y value. And the function takes on that y value because it's a closed circle there. So let's write that y is greater than or equal to -5. And how about the highest y value? Well, that's all the way up here. So let's count until we get there. That's 1, 2, 3, 4, 5, 6, 7. So that's a y value of 7. But that's an open circle, so it doesn't actually attain the value of 7. It only goes up to 7. So y is less than 7. Alright, so that's our range, and we can turn that into a nice interval notation, beginning with -5, and that gets a bracket because that allows equality, and then ending with 7, and that gets a parenthesis because equality is not allowed. So there we go. There is our range. Now we know how to find the range of a function, and in the future we'll continue learning about more properties of functions, such as their roots.